This time, we are going to write a PLC program to change the direction of the motor rotation so that we can move this conveyor belt right and left. Let's see how we can do this. As we have seen in the previous lessons, to turn on a three-phase motor, we usually use a contactor to switch the incoming power. We connect a PLC output to the contactor's coil to control it. As soon as the coil is energized and the contacts are closed, the power begins flowing to the motor. Let's say that with this single contactor, our motor will turn clockwise when energized. To reverse the direction to counterclockwise, all we need to do is swap any two of the phases. To do this, we are going to add a second contactor. Both contactors will be connected in parallel to the incoming power. On the motor side of the new contactor, we will swap the S and the T phase connections. With this wiring, when the first contactor is turned on, the three-phase power connected in the order R, S, and T will cause the motor to turn clockwise. When we turn on the second contactor, the three-phase power is now connected to the order R, T, and S and will cause the motor to turn counterclockwise. It should also be noted that we will never be turning on both contactors at the same time. That's how simple it is to change the direction of motor rotation. Just swap any two of the phases and you're done. From now on, we'll call this contactor clockwise and this one counterclockwise. To energize the coil of the clockwise contactor, we can use this start switch here. And for the counterclockwise contactor, we will add another start switch and connect it to the second input of the PLC module. To stop the motor regardless of which direction it is rotating, we will add a stop switch here. Okay, with this wiring diagram, writing our PLC program will be very clear and easy. We will write the program so that when the clockwise start switch is pressed, the motor will rotate clockwise, and when the counterclockwise switch is pressed, the motor will rotate counterclockwise. We have three inputs, which, just as in the previous program, are connected to the IOO, IO1, and IO2 inputs. We also have two outputs that are connected to the Q4O and Q41 outputs. To save time, we have already filled in the symbol table based on the inputs and outputs that we have. So now, let's save the table and go to the OB1 to write our program. Okay, as a first step, we are going to add an SR flip-flop here and give it the output address of the clockwise contactor. To energize this contactor when the clockwise switch is pressed, we are going to add a normally open contact here and assign it the address of the clockwise start switch. To turn the motor off, we are going to add a normally closed contact on the reset input and assign it the address of the stop switch. Here is an important step. When our motor is running in the counterclockwise direction, we do not want the clockwise start switch to work, and vice versa. We want to make sure that our motor must be stopped before it can reverse direction. To do this, we're going to add a normally closed contact here and assign it the address of the counterclockwise contactor. Now, when the counterclockwise output is on, the clockwise start switch will not work. The motor must first be stopped, and then it can be started in the opposite direction. Okay. Now we have our finished program for the clockwise mode. The counterclockwise program is very similar to this one, only with different addresses. So, what we're going to do now is copy this network and paste it here, and then change all of the addresses for the counterclockwise mode. Now, we will save the program, and then drag the OB1 to the online window to download it to the CPU. As always, before testing the program, we're going to put the program in the online mode, and then energize the stop switch since it is a normally closed switch. Now, To test the operation of the contactors, we'll go ahead and energize the clockwise start switch, and as you can see, the PLC energizes the output to the clockwise contactor. When this contactor is energized, these contacts here will close and cause the motor to run in the clockwise direction. Now, if we press the stop switch, the PLC output turns off, which de-energizes this contactor, and as a result, these contacts open, which turns off the motor. Now we will press the counterclockwise start switch, and as you can see, the counterclockwise contactor is energized. Since the S and the T phases are now swapped to the motor, it will run in the counterclockwise direction. You can also see in the WinCC flexible graphic that the motor is rotating counterclockwise. Since the counterclockwise contactor is turned on, if we press the clockwise start switch, the signal cannot pass through here, and we are not able to reverse direction. If we press the stop switch, and then press the clockwise start switch again, this time the motor is allowed to reverse direction. So anytime we need to reverse the motor rotation, we can press the stop switch and then press the relevant start switch. Okay, this was the normal mode for controlling motor rotation. Now, we want to change this program so that we don't have to press the stop switch to change direction. Our motor will begin rotating in the direction we choose as soon as the start switch is pressed. Let's go to the next lesson to see how we can do this.